Okay. So, in answer to the question that came up with Kathy, I want to recount something I said some time ago, which is that if you attach enough rocket boosters, then a pig will fly. And I made that comment in IPv6's infancy, which have in fact been attached. And so I'm riding the pig. I want to thank Jinmei for helping with these slides. He can't be here today, but you'll recognize, some of you might recognize some of his views and his work. So to develop an IPv6 name server will require, among other things, that you take a very different approach toward your system calls than has historically been done on POSIX-style systems. There's an RFC, one of few that I've seen that actually tries to document an API, but there is an RFC by Matt Thomas and some other people that I think cleans up a lot of the socket model and gives you a much better handle on sort of what you should do if you're a multi-homed host and you want to make sure that your UDP responses go out with a source address that corresponds to the destination of the packet you're answering. That used to be very difficult. Now it's very easy. There were some config changes to the named.conf for IPv6 handling. Largely this just means that in places that a CIDR address used to be just IPv4, it's now also v6. But it must be noted that, again, because of the way you listen, it's a little bit harder on a v6 machine to decide which interface you will listen on. So there's a slightly different syntactic model about how what you do with listen on. And that was not our idea. That was just sort of what we had to do to let the v6 community do what they wanted. Some of you may have heard of an interim proposal called A6. Instead of the quad A record that you see now, there is going to be a sort of multi-segmented A6 record that would let you build an address by more or less having a path through the ISP or the RIR who had delegated you the space, so that you would only have to recount your part of the address, and then DNS clients who were trying to build the address would get the other parts from the other people who actually hold that part of the address space. And it was I think, one of the few truly interesting and new parts of v6 for DNS, but it turned out to be too interesting and too new. And the reliability problems that would be caused if you were multi-homed and had several different name servers, you could end up sending hundreds of packets. Including if DNSSEC was also involved, you could send hundreds of packets just trying to do a get host by adder, and that was just not reasonable in the eyes of many. So that was taken out. So if you looked into IPv6 early and you saw A6 records and you said this is not for me, take another look. It's gone. One of the things that went with it is the bitstring label type. This was a way to have, basically this is where the magic happened, so that if you wanted to do allocation to other people's PTR zones on a bit boundary rather than on an octet boundary or a nibble boundary or any other boundary, you could get that done. And certainly, if the world had been full of /35s, then we might have seen a little bit more popularity of that method. But when you have 128 bits, it's pretty easy to find a convenient 4-bit boundary to do your delegations on. So again, bit strings are gone. And if you looked in on the performance of bind version 9 early on and said that it was not for you because it was too slow, again, take a look again when 9.3 comes out, because when we took bitstring out, a lot of the generality went with it, and the queries per second went up perceptibly. And DNAME, I'll be coming back to DNAME, is one of the things that was put into the spec to support A6 and bitstring. It's sort of part of the whole equation, but it has not been taken out. So even though the other things that gave rise to it are gone, dname is still there. And I guess the way to think of dname is that it's like cname, but it is additive rather than replacing. And again, I'll come back to that. And in testing these things, clearly most of the IPv6-enabled hosts on the network are dual stack. I do run into some purists once in a while who will boot with just their v6 stack just to see if they can, or just to prove that they can, or just to find out why they can't. But that's, even though you might think of v6 people as zealots, because after all they're sort of compellingly interested in something that does not fascinate you at all, they're not all purists. And so most of them you'll see will use a dual stack host. And so they have both a v6 and a v4 address. And in that environment, you have this wonderful crutch where you could be using some kind of a fallback code path to go get your work done, and never know it until some purist comes along and tries to run your code. So it's important when you're testing to find out what happens when you are a single stack machine in an otherwise dual stack world. Zone reachability is one of the application layer problems that various folks are still working on, and hopefully Anand will come up to the microphone and give us a snapshot on that. What I mean by reachability is if you have a zone that only has quad A records for its glue records, so the only name servers that it publishes are in v6 space, and you are a single stack machine with only a v4 address, what ought you do? And the reverse problem is probably more common, where if you only have v6 addresses on your computer, but you have to reach a v4 name server because, gee, you've been referred to someone who only has A records for their glue, what ought you do? So I think we'll have some help with that during the Q&A. Obviously, answering authoritatively on v6 is pretty easy, but in our testing we also wanted to make sure that we could answer zone transfers, initiate zone transfers, fall back appropriately if somebody specified as the master servers for a zone collection of both v6 and v4 addresses. So all of that came up in the test plan as well. Forwarding, one of the things we do is we have a v6 reachable name server that does the recursion and forwarding. So it's the thing you put in resolve.conf is dual stack. So if you as a purist are inside my LAN, you'll be able to talk v6 to a server that is then able to chase down both A records and quad A records. So that's the crutch that we happen to use. There are other approaches that look more like NAT that perhaps we'll hear about. So all of these things were ultimately made to work before we started releasing snapshots that claimed to support v6 transport. So I will say that a /32 is a lot of space. About half of it goes to a LAN, just the way that they do the mapping of addresses inside of 802.1 network is that they need a /64 to make it work. And so 48 of those bits go into the MAC address, and then 16 other bits go into various other things. So that means you are limited to only 4 billion LANs inside of a /32. So be careful with that. In our case, where you see the W, X, Y, and Z, we have a number of just zeros that are intended for a future expansion, and then we have some site codes, and then within site codes we have sort of VLAN tags. So on the /48 that we will use for FROOT, they gave us a /48 because they knew we would be filtered if they gave us a longer prefix than that, but I only need one address. So we're dedicating an awful lot of bits to just representing that one thing. And yes, as Kathy said, you can spell things. It's a lot of fun. You see a lot of dead and beef and things like that in these addresses. In my case, I used 1034 because that's the RFC that gave rise to the protocol. So there is fun that can be had. Now, in operating these, we had to upgrade an infrastructure of a whole bunch of bind 8 servers to run bind 9. And sorry to say that we didn't really do that in earnest until we started using V6. So my normal policy for ISC is that we so-called eat our own dog food. You know, we run the same software that we publish, but when you have two major releases that are both still in production and both still getting release cuts once in a while, then you can kind of decide which one you want to run. And so the one that got run was the one that had been getting run for years previously. But when the ops people inside of ISC started running bind 9, they discovered all sorts of things that were just terrible. Just the lack of syslog and the lack of feedback from the RNDC command were two things that had to get fixed the same day that deployment happened. So if you've seen any improvement in that, then you know where it came from. Now it's eerie to folks who run high-volume name servers to switch from bind 8 to bind 9 because you'll do a PS command and you'll see no named-expr commands in your process table. That's gone. So this now just does everything internal to the one process and has its own multiplexing and task switching internally. That it almost overcomes the fact that it uses a lot more CPU cycles per query. But again, you can put multiple CPUs to the task. So if you have one of these high-performance multiprocessor Xeon or Solaris, Spark Alpha, whatever it is, if it's got a lot of CPUs, bind 9 will use them all, and it needs them all. And it will need more memory as well. We generally notice about a 25% bloat just going from bind 8 to bind 9 with the same set of zones loaded. And then you'll notice an additional 25% bloat if you go from a 32-bit machine to a 64-bit machine, because a lot of the memory footprint is just pointers. But, Moore's law says that successful software companies should be finding ways to use all of this new silicon, so we're doing our part. Now, there are name servers out there that really do some bad things. So, for example, if you ask them a question about a quad A record at a given node, even if there are A records at that name, they will tell you that the name itself does not exist. And there's some interesting fallback behavior written into the IPv6 transports in order to cope with this possibility. Because you could be referred to a zone and you could be trying to do the right thing. Gee, are there any quad A records that I should be using in order to use V6 transport between he and I? And you'll be told, well, not only are there no quad A records, but the zone you were delegated to doesn't really exist. And so we actually retry in some cases using A, even after we've been told that the name doesn't exist, because there are these other implementations out there that are just terrible. You can also have a load balancer that will answer a query for an A record, but it just won't answer anything else. It doesn't tell you anything. So again, in some cases, we treat a timeout as a need to retry using a different query type, or it's just this stuff is terrible. And I think in the next year or so, I'm hoping that ISC will be able to produce some conformance test software rather than just interoperability testing, so that we can start calling these people out and making them fix their stuff. There was a political mess that led to renaming IP6.int over to be IP6.ARPA. And this happened after 6bone had been a moderate success, and quite a few of those /32s and 35s that were on Kathy's slides had been allocated and were in common use. And so somebody really slipped on a banana peel when they made that change so late in the game. Now, V6 has some arcane things in it, one of which they call site local, which you can sort of think of as RFC 1918, but the exact definition of what a site is kind of still up in the air. It doesn't exactly correspond to an autonomous system, nor to a LAN, nor to a campus, nor to a building. But it could be any of those things depending on how much cooperation you have inside of what you want to call a site. But in any case, they are ambiguous addresses, and DNS won't work for them. Link level is a similar sort of thing. If you really are sure that you will never have to communicate with someone off the current LAN or off the current point-to-point, then you can agree to use an ambiguous prefix that is in use on every other link on the internet also, and DNS won't work for those either. So it's like 1918 in v4 space. You have to set up some local zones and to make sure that you direct all the queries about those zones to your own servers if you want naming to work in those address spaces. There's a privacy extension that will almost certainly go forward that has yet another kind of address, which is very temporary and is not expected to ever have working names, nor need them. A lot of us on our DHCP networks, we will generate a whole bunch of names just so there can be names. They're sort of meaningless, but they will be like, in this case, DHCP204.foo.com would be the .204 address on some LAN somewhere. And if you have 64 or even 256 or a /20 or whatever it is, you can pre-assemble all those names so that once somebody receives a DHCP address from you, there will be a working name. It might be up to them to discover it and use it, but at least there will be one. In this case, that's just not realistic because the address will include their MAC, and so there's no way to know in advance what where to put the PTR. So there has been a standard whereby you do a dynamic update after you complete a DHCP transaction, and that is probably going to be more popular in v6 than it was in v4 because this little trick doesn't work anymore. If you start using this, you will undoubtedly end up using the dig command to find out why whatever it is you or someone else is doing is not working. And when you do that, you're going to notice that there's this extra OPT record that is coming back to you and also going out from you when you do a query using Bind9 tools or any other modern tool. And that's so that the requester, the person who is sending the query, can tell the responder, which in this case is the server, exactly how big the buffer is that the response needs to fit into. Because the default, the implicit default in v4 was the 512 octet limit. And that was causing a lot of truncation because, of course, quad A records are bigger. DNSSEC signatures and keys are also very big. So we needed to expand that. This was the way we did it, and it's been gathering strength in the course of the last 2 or 3 years. We're adding more features to EDNS as time goes forward and bumping the version number, but they're all backward compatible, so that part is a success. And for the root name servers, it turns out that EDNS is absolutely critical. If you want to be a purist and you want to be a single stack v6 host, then one of the things you have to be able to find is a root name server that will answer you in v6 land. And there are various test beds and experiments out there to help you do that, but we need to, for example, the f.rootservers.net name needs to sprout a quad A record so that when you get a delegation, you get at least one v6 reachable root name server. There are actually 4, but there's no room in the response right now to put those quad A records in. We're bumping up against the 500 byte limit now. So with EDNS, we will actually have room in the response to delegate you to a mixture of a couple of different kinds of servers instead of just the v4s. There has been continuing interest in, gee, could you please add v6 transport to bind 8? and that's from folks who either feel like they can't afford the additional CPU cycles or memory footprint that it takes to run Bind 9, or maybe they are using an older platform like, Sonos 414 or something like that doesn't support Bind 9. There could be a variety of reasons that people want to do the V6 transport, but they just can't run Bind 9, and it may yet come to pass. No promises. Although I will say, ISC is a not-for-profit, so money talks. And that's pretty much my talk. So I had a slide or two to show if I had any minutes left, but we've also got time for questions. Okay.
Paul, this is Craig Hegan. Do you foresee DHCP still being pretty big, and if so, from a name server perspective, instead of relying on the client to push its name up via dynamic DNS update, do you foresee the capability of the DNS servers to automatically generate those, those records automatically for the DHCP entries we've relied on?
Well, the host name that I gave, dhcp204.foo.com, was really kind of a placeholder. It's unlikely that the client was going to change its host name to correspond to that following a DHCP transaction. So it's really just there to keep get-host-by-adder from failing or timing out or something. So if you go to an FTP server that checks such things, then they will find something for their log file. But the real desire is that the client has a name, he knows what it is, and he would like the DNS to reflect that after a successful DHCP. And I think if V4 really is still in use 10 years from now, you'll see that that's a pretty popular kind of thing to do. But in V6 land, they have this stateless autoconf that is, some people say, better than DHCP, but it also means that there is no server out there that knows when you have been allocated an address, so there's no one to act on your behalf to go make some DNS transaction to go update your name. It's likely that the DHCP server, because it is owned by the same guy who runs the LAN, has some TSIG keys and other permissions to go make that update, and that you, as a stateless autoconf client, do not.
Right.
So I expect that the ability to do get host by adder and put something useful into the FTP log file is going to go away.
From a large corporate perspective and maintaining a pretty significant network, we don't necessarily trust a lot of the end users and the host names that they would push toward DNS. And so many times, also we're looking for the audit trails associated with being able to track down a host, and relying upon, say, MAC addresses or tracking down MAC addresses or even private addresses from cards. DHCP gives us at least a little bit more control. And so the idea of using the servers, being able to generate predictable host names based upon that for readability purposes is something that
I know, but the people who worked on the standards in this area traded your concerns off against some others, and you got screwed.
Thank you.
On the same topic, on the reverse path, on addresses that were created by stateless auto configuration, one of the solutions that we were looking at was using wildcards and somehow populating the reverse tree up to the equivalent of /64 and then putting up a wildcard to match all the potential machines from a single subnet. Or if you are an ISP with home customers, that may be what you want to do. So I would like to ask this community if it is something totally unacceptable because you maybe could not sign it using DNSSEC, or if it is something that you will be willing to live with.
I think you would need to give them a lot more detail before you'd get much of an answer, and I don't think we're going to get time to do that. Is there a draft they can read?
Yes, there is one. and it's going to be updated and published soon again.
Okay.
I think it will be in the DNS Up community, so look for drafts in DNS Up.
Okay. That's on www.ietf.org. Go off to Internet Drafts and look for DNS Op. So, I don't see anyone else at the microphone. I want to show you these graphs. This shows that FRoot was attacked about 8 hours ago with a 50 meg spike of query traffic, and it was attacked last week on Monday with an attack of slightly greater magnitude. The one from Monday made the papers. The one from 6 hours ago did not, and in my opinion should not. It's no big deal. If I had better graphing tools, I could show you that this is a pretty common event. Since we have some network owners in the audience, I also want to show you this is your brain on drugs. This is one of a number of worldwide Anycast servers that serves 10.inadder.arpa, and these are your customers pounding us. This is down here. You'll see 5,000 times a second. Somebody comes to our particular instance of this and says, "Hey, I want to update a name in RFC 1918 space," or "I want to know my name in RFC 1918 space." And there are tools available where you can collect these queries locally and answer them locally, and maybe even give true answers regarding your own use of these 1918 space inside your autonomous system. You don't have to send them to me. I'm just going to say that the name doesn't exist. But anyway, thank you.